This is homework number 9 and we're going for question 7 where I have to sketch the parabola y is equal to x squared plus 6x plus 5. Okay, I'm going to do it two ways. The first way I'm going to do it is I'm going to use a bit of differentiation for it, and the other way that I'm going to do it is I'm going to complete the square. So two ways that I could approach this type of question here. Right then, so the first thing I'm going to do is to find out where the curve itself cuts the x-axis. So what I'm going to do is I'm going to let y equal to 0 in here. So I've got 0 is equal to x squared plus 6x plus 5. What I'll do is I'll put this into two brackets which will find me the factors. Okay, x and x multiply together to x squared. 5 and 1 are the only things I can use. There's going to be plus signs in between there. And what I'll do is from there I can see that x plus 1 equals 0. So x equals minus 1, x plus 5 equals 0, so x equals minus 5. So there's the coordinates of where I'm going to find it cutting through the x-axis. So that coordinate there will be minus 1, 0. This one here, minus 5, 0. So that's we got the two of them. Right, so how about letting x equal to 0, and that will help me find out where it cuts the y-axis, and that's what I'm interested in here. So what I'll do is I'll start with the equation and just substitute the x values in. So 0 squared plus 6 times 0 plus 5, well that just gives me y equal to 5. Okay. And the coordinate that I'm going to get from here is going to be 0, 5, and that cuts through the y-axis. So that's me got the x-axis intercepts and the y-axis intercept as well. What I'll do is I'll go back to the curve. What I'm going to do is I'm going to differentiate it first of all. Okay, 2x plus 6 comes out of there. So I know that dy by dx, what I could say is for stationary points, so that's me trying to find out where this is going to turn. For stationary points, I know that dy by dx is going to be equal to 0, because that's going to be the gradient of the curve. So I know that the gradient is going to be equal to 0 at a turning point. So just set that equal to 0. Take the 6 over to the other side, that'll give me a minus 6 is equal to 2x. So from there I can see that x is going to be equal to minus 3. What I'll do to find the y coordinate, I'll substitute x equal to minus 3 into the full equation, okay, into y equals x squared plus 6x plus 5. Right, so that would give me y is equal to, and we'll go for minus 3 squared, it's going to be plus 6 times minus 3, and then I've got a plus 5 would be there. Okay, so if I work that through, that's going to give me an answer of minus 4. So I know that my turning point, or my stationary point really, is going to be equal to minus 3 and minus 4. Okay, so from there what I'd do is I'd do a nature table. Okay, and so my nature table would be made up of, I've got one point that I know that it's either going to turn or be a point of inflection. I've called it a turning point down here. I know it's going to be that, but really what I'd be doing is I'd be calling it a stationary point at that time. So I've got x is going to, the coordinate I'm going to use. I've got the minus 3, which was the one that I know that the stationary point is at, and I know that the gradient dy by dx is going to be equal to 0 at that point there, so it's flat. So what I'll do is I'll consider just to the left, I'll think about the number minus 4, because I want to know what the gradient's like as it approaches that point there, and I want to know what it's like when it goes away from it. And minus 1 would be an easy number to use there. If I substitute these numbers into this equation here, what I would get is I would get a negative answer coming out of there. If I substitute minus 1 into 2x plus 6, I'm going to get a positive value coming out of there. So what that tells me is that my shape of the curve is going to be equal to a negative gradient, which will be coming down the way like this. I've got it flat when it gets to 0, and then a positive gradient from left to right going up the way there. So that there is a minimum. Okay, So what I have is, I'll just say that the turning point is a minimum, and it's at the point -3, -4. Okay, and that's all I need to draw the curve. So that would be me set up. Right, so what I'll do from there is I'll just do a quick sketch of it down here. Go along here this way here. Right then, so if I know that we've got the coordinates I've got is -1, 0, so if I call that just -1 along to there, -3, -4, -5, so that'll give me a -5 here. That one there will be -1. Okay, and I know that it's going to cut the y-axis at the point, let's see, 0, 5, so it'll be 1, 2, 3, 4, and I'll just say that 5's about here. Okay, that'll be my y-axis going up there, x-axis going that way there. I know the turning point is -3, so here's -3 here, and it's going to go down 4 places. So there we go. So that's my turning point, and that point there is -3, -4. So I've got all the points I need to draw the curve, so let's go and see how we can do that. Just draw it up to there, turn there, and just come back up through the x-axis there, and back through the y-axis, where that was the point 0, 5. Okay, and that would be my curve drawn, and that's what I'd be expected to do. Let me just show you if you used the completing the square method. I'll just put a box around that here, and what we'll do is I'll show you how I would go ahead and do that. So thinking about the completing the square method, what I would do is I'd be trying to complete the square on y is equal to x squared plus 6x plus 5. So the way I would do it here is I'd find half of this coefficient here, and that would be 3. What I would then do is I would substitute it into a bracket, so it's going to be x plus 3, so that goes in there. I'm going to take away, this is going to be a square bracket, this is going to be taking away the 3 squared, and I've got a plus 5 at the end there. So that there gives me x plus 3 squared, I've got -9 coming out of there, and I've got a plus 5. So my answer here is x plus 3 squared -4. And from there I can see that my turning point, and I can see it's -3 because it's the opposite of this one here, and I take this value down. So that's the same work that I've done there to get the stationary point or the turning point from there. I know that it's a maximum because I'll just put something down that would state that since the x squared, and that would be this x squared here, if that's a positive, if x squared is positive, okay, if that's positive, the curve, or I'll say the turning point is a minimum. Okay, so that's this question complete here. What I'll do for marking, right then, so first thing I'm going to do is I'm going to get a mark for factorising this part here, okay, and I want that to be equal to 0. I'll get another mark for the roots, or the x coordinates actually, that I'll take from there, and what I'll do is I'll get one mark for getting the y coordinate of where it's turning there. I'm going to look for a mark for differentiation, so I'll get a mark for differentiating this correctly, and from there I'm just going to take a mark for getting the turning point correct there. And finally I'll get one more mark for, let's see, just what we'll go for is just drawing the curve correctly. So the marks for this one here, I'm going to go for 1, 2, 3, 4, 5, I'll go for 6. So this is going to be out of 6 marks.